Can the sky really quench our thirst? Can rainwater become drinking water? Can the ground beneath our feet become a giant water bank? Can groundwater recharge reduce salinity and solve the freshwater crisis in the Sundarbans? TekBerry made it happen. A landmark project in Bengal's UNESCO mangrove forests.
Hello everybody. We have from TekBerry designed a rainwater harvesting scheme for village Godhkhali, who had extreme problems with water during the summer period. Hence, we were approached by people who are at the helm of affairs to try and sort out their problem of drinking water, especially for the children. About 600 to 700 children who study in the school, and also alongside the villagers who stays nearby. So this has been a huge boon for them, as now they get clean water, which has been approved by the public health engineering laboratory as to the water is of potable quality. So in fact, in this area, apart from rainwater harvesting, we have also done groundwater recharge. The water level in this place has from 300 to 400 feet has now dropped to around 1500 to 1700 feet. So this has become a problem, and it also increases salinity. So now we are also recharging through a recharge borehole the groundwater as much as possible, so that in due course of time the salinity reduces progressively and the water table also comes up. So that this should be a good project for the village Godhkhali as well as for all villages around surrounding this. Thank you.
In the heart of the Sundarbans, at Godhkhali's Maitipara Flood Center, young Indians initiated a project on rainwater harvesting, where TekBerry was invited as the technical partner to do the project designing and engineering supervision of the project. At latitude 22.168614 and longitude 88.77351, their journey began, crafting an innovative system to harvest rain and restore the hidden aquifers beneath. The Sundarbans face a double challenge. Groundwater lies over 1,000 feet deep, making it hard and costly to access. Even existing borewells' water is often too salty to drink, as tidal flows and rising sea levels push salt into the aquifers, leaving communities with water that is both scarce and unsafe. The project focused on 5 key objectives: to provide a reliable water supply through rainwater harvesting, ensure clean water with advanced filtration, recharge groundwater with excess rainwater, empower the community to conserve water, and promote sustainability by integrating renewable energy and reducing carbon emissions. Rainwater is collected from a rooftop area of 4,000 square feet, with the capacity to harvest 5 lakh litres annually. At the core of the system is a self-cleaning primary filter. Rainwater, along with debris, enters tangentially into the rainy filter housing and rotates slowly along the periphery. In low rainfall, cohesive force ensures dirt is separated from clean water. In heavy rainfall, the high-velocity flow creates centrifugal force, which drives impurities outward. The SS304 filter element then diverts clean water into the reservoir or recharge wells while automatically flushing out sand, debris, and dirt through the drain outlet. This ensures that only clean water moves forward for storage and treatment. A reinforced underground reservoir, with a capacity of 2 lakh litres, was constructed at the site. From here, a pumping system with a discharge rate of 4,000 litres per hour lifts water to overhead tanks. Before reaching these tanks, water is treated using a turbidity filter and a chlorine dosing unit, ensuring it meets potable standards. The system is powered by a solar hybrid pumping unit. During clear weather, the pump runs entirely on solar energy, and during the monsoon, an electrical backup ensures uninterrupted supply. Excess rainwater is not wasted, it is directed through media filters into specially designed recharge wells. These wells extend 200 to 300 feet below ground, enabling water to percolate back into aquifers. This process not only replenishes groundwater reserves but also gradually reduces salinity and improves the overall quality of groundwater, ensuring long-term sustainability for the community. The success of this project lies in community participation. Young Indians Kolkata adopted Godhkhali village in January 2023, combining water security with women's empowerment initiatives. Locals were trained to operate and maintain the system, while awareness programs encouraged conservation. Let's hear from the villagers of Godhkhali themselves, how this project has transformed their daily lives and brought real change to their community.
আমার নাম গোপাল দাস। আমি এই মুর্শিদাবাদী অঞ্চল এবং গ্রামের নাম গদখালি, সুন্দরবন প্রত্যন্ত এলাকা, একটা পিছিয়ে পড়া গ্রাম। আমরা পুরো জানুয়ারি থেকে একদম এপ্রিল মে পর্যন্ত আমরা গ্রামের যে সমস্ত ডিপ টিউবওয়েলগুলো আছে আমরা জল পাই না। কিন্তু আজকের এই রেন ওয়াটার যে হারভেস্টিং প্রজেক্টটা আমাদের করেছে, এখানটা আমাদের দুখানা স্কুল আছে, না হলো 700-800 স্টুডেন্টস আছে। এই স্কুলে যে সমস্ত বাচ্চারা সব এই জল ব্যবহার করছে, মিড ডে মিলে রান্নার কাজে লাগছে। এবং যে গরমের সময় আমাদের তো জল পেতাম না, যে সমস্যা, বড় একটা সমস্যা, বাচ্চাদের পুকুরের জল নিয়ে অনেকটা থালা বাসন হাত ধোয়ার কাজ করতো। কিন্তু আজকের এই ধরনের যে প্রজেক্টটা আমাদের গ্রামে আমাদের সঙ্গে আমাদের কাজ করেছে, তার জন্যে আমি বলি এই জলের সমস্যাটাও সমাধান হয়েছে। এবং স্কুলের যে 700 থেকে 800 বাচ্চা আছে তাদের বিভিন্ন কাজে উপকার লেগেছে। একটা ড্রয়িং করেছে, প্রজেক্টটা কমপ্লিট করেছে TekBerryকে। আমাদের গদখালি গ্রামবাসীদের পক্ষ থেকে ওদেরকে অসংখ্য অসংখ্য ধন্যবাদ। গ্রামেরও মায়েরা এখান থেকে জল নিয়ে উপকৃত পাচ্ছে। এই জলটা নিয়ে আপনারা কি করছেন? আগে কোথা থেকে জলটা কাজ করছেন? পুকুরের জল ব্যবহার করছেন নাকি? কলের জল পাওয়া যায় না ঠিকঠাক। এখন মোটামুটি এই জল নিয়ে আমাদের স্কুলে কাজে লাগছে এবং রান্না বান্না সব কাজে লাগছে, মিড ডে মিলে বাচ্চাদের দিনেও লাগছে। মানে খুব কাজে লাগছে। তোমরা সব জল নাও এখান থেকে এসে, খুব সুবিধা হচ্ছে না, পুকুরে যেতে হচ্ছে না। এখানটা পাওয়া সমস্ত জল এখান থেকে কালেক্ট করো। বাহ, তোমাদের স্কুলের নাম কি শোনা? গদখালি হেনময়পুর প্রাইমারি স্কুল, তাই তো? বাহ বাহ।
That assurance came through comprehensive water quality testing. Chemical parameters analyzed included pH, total dissolved solids, alkalinity, iron, chloride, and total hardness. Microbiological testing confirmed the absence of coliform organisms and E. coli. The results validated that the water meets safe drinking standards for the community. The outcomes are already visible. A sustainable supply of safe drinking water for as many people across nearby villages. Elimination of the need for villagers to travel kilometers or purchase expensive drinking water. Reduced incidence of waterborne diseases like diarrhea, particularly protecting children and vulnerable families. Water used daily for drinking and cooking of midday meals. Groundwater replenishment and salinity reduction, addressing the summer crisis when pumps traditionally dry up. Reduced dependence on deep groundwater extraction. Lower carbon emissions through renewable solar power integration. This model has strong scalability potential, with recommendations to expand rainwater harvesting to nearby villages and schools, implement similar systems in other community structures, and continuously monitor water quality and system performance for long-term benefit. This project at Godhkhali showcases TekBerry's vision and expertise. As a leading water infrastructure firm, TekBerry transforms scarcity into security through innovative rainwater harvesting and groundwater recharge, building resilient systems that empower communities. For TekBerry, every drop counts and every solution matters. Thanks for watching. Don't forget to like, comment, share and subscribe to our channel.